Let g1, g2 and g3 be the roots of the polynomial qx is equal to x raised to the power of 3 minus 9x square plus 1 if Rx is equal to x to the power of 5 minus x square minus x, then what is the value of R of G1 plus R of G2 plus R of G3? Since G1, G2 and G3 are the roots of the equation Qx is equal to x cubed minus 9x square plus 1, it follows that Qg1 is equal to G1 to the power 3 minus 9x square plus 1 is equal to 0. Let us call it equation 1. Similarly, for Qg2, we have G2 cubed minus 9G2 squared plus 1 is equal to 0. Let it be equation 2. And finally, Qg3 is equal to G3 cubed minus 9G3 squared plus 1 is equal to 0. Let us call it equation 3. Rx is equal to x5 minus x square minus x. This is given. By long division of Rx by Qx, we get a quotient of x square plus 9x plus 81 and a remainder of 9 cube minus 2x square minus 10x minus 9 squared. That is, Rx by Qx is equal to x square plus 9x square plus 81 with 9 cubed minus 2 multiplied by x square minus 10x minus 9 square left out. Or Rx is equal to Qx multiplied by x cube plus 9x plus 81 plus 9 cube minus 2 multiplied by x square minus 10x minus 9 square. Since for each of G1, G2 and G3 Qx is 0, it follows that Rg1 is equal to 9 cube minus 2 multiplied by G1 square minus 10G1 minus 9 square is equal to 4. Similarly, Rg2 is equal to 9 cube minus 2 G2 square minus 10G2 minus 9 square. Let us call it equation 5. And finally, Rg3 is equal to 9 cube minus 2 G3 squared minus 10G3 minus 9 square is equal to equation 6. This is because the first term in this equation, that is this term, becomes 0 because this is given to be 0, Qg being the roots of the equation Qx. So we get, by adding the three equations, Rg1 plus Rg2 plus Rg3 is equal to 9 minus 2 multiplied by G1 square plus G2 square plus G3 square minus 10 multiplied by G1 plus G2 plus G3 minus 3 9 square. Let us call it equation 7. Are you familiar with Vieta's formula? If not, let me write it down without proof. We know that if Px is a polynomial with nth degree, that is Px is equal to an multiplied by x to the power of n plus a n minus 1 x to the power of n minus 1 plus a n minus 2 x to the power of n minus 2. It will continue. Finally, a1x plus a0. Then px has n roots, whether real or complex. Vieta's formula relates the coefficients of the polynomial with the sum and the product of the roots as stated below. If R1, R2 and etc. Rn are the n roots, then R1 plus R2 plus Rn is equal to minus an minus 1 divided by an, and R1 R2, R1 R3, R1 R4, R1 Rn plus R2 R3, R2 R4, it will continue up to R2 Rn plus the final term is Rn minus 1 multiplied by Rn, and that is equal to an2 divided by an. And like this it will continue, and R1 multiplied by R2 multiplied by R3 Rn is equal to minus 1 to the power of n a0 by an. For a polynomial of the third degree, say ax cubed plus bx square plus cx plus d, Vieta's formula gives x1 plus x2 plus x3 is equal to minus b by a, x1 x2 plus x1 x3 plus x2 x3 is equal to c by a, and R1 multiplied by R2 multiplied by R3 is equal to minus d by a. Other terms like R2, R4, R3, R4, etc. do not occur because R4, R5, etc. do not exist in a third degree equation. Coming back to our problem, qx is equal to x cube minus 9x square plus 1. This is a third degree equation with the roots being g1, g2 and g3, comparing with the general third degree equation, that is ax cube plus bx square plus cx plus d. We get a is equal to 1, b is equal to minus 9 and c is equal to 0, and d is also equal to 1. Using Vieta's formula for third degree equation, we get g1 plus g2 plus g3 is equal to minus b by a, that is 9. Let us call it equation 8. Then g1 g2 plus g1 g3 plus g2 g3 is equal to c by a, which is equal to 0. Let us call it equation 9, and g1 g2 g3 is equal to minus d by a, which is minus 1. Let us call it equation 10. From equation 7, r of g1 plus r of g2 plus r of g3 is equal to 9 cube minus 2 g1 square plus g2 square plus g3 square minus 10 g1 plus g2 plus g3 minus 3 multiplied by 9 square. Or this term here can be further written down as follows, that is r1 g1 plus r2 g2 plus rg1 plus rg2 plus rg3 is equal to 9 to the power 3 minus 2 g1 plus g2 plus g3 whole squared minus 2 g1 g2 plus g2 g3 plus g1 g3, and then these two terms follow, that is 10 G1, G2, G3 minus 3 multiplied by 9 squared. Using equation 8, 9 and 10, yielding Rg1 plus Rg2 plus Rg3 is equal to 9 minus 2 multiplied by 9 square minus 2 multiplied by 0 minus 10 into 9 minus 3 into 9 square, that is equal to 729 minus 2 multiplied by 81 minus 90 minus 243, which works out to 58,554. Therefore, R of G1 plus R of G2 plus R of G3 is equal to 58,554. Now, this is a problem involving an equation of a third degree which is difficult to solve. There are various classical methods of solving it, but the roots come out to be very inconvenient. They are not even fractional. They are they have many points and they do not end. Like 2.5369778, like this it will continue. Therefore, without calculator, we cannot multiply or divide or do anything with them. So, I have found that the above stated formula and equation are the best ways of solving this type of equations. Thank you.